So previous session talking about the introduction of a new alphabet, the stack alphabet. Typically PDA has two alphabets, the input string alphabet, sigma, capital sigma, and now this new one, the stack alphabet. That's the set of symbols that can be used on the stack that you push and pop onto the stack, and that alphabet is usually represented by a capital gamma like this. Okay. Now, before moving on talking about the transition function of a PDA, a bit of a reminder. Now, we've seen this before. Is you just add the empty string, the epsilon, to a set of the empty string to this alphabet. Okay, so you just union it with the set of the empty string, and you write that as capital sigma suffix epsilon. Well, you do something similar with the stack alphabet. So capital gamma suffix epsilon. So similar definition. So this alphabet and this alphabet, both of them will include the empty string. Okay, epsilon. All right. Now let's talk about the transition function. That's always the kernel, the core, the guts, the heart of an automaton. Right? In the case of finite automata we did earlier, its function, the transition function, was to look at the current state and the current input symbol in the input stream, and on the basis of those two numbers, those two things, to decide what the next state would be. Okay. Now in this case things are a little bit more complicated, because now we're talking about a PDA. Okay. And there's an extra variable, there's an extra factor involved, and that is the stack. Okay, so the transition function now will, let's see, so be the PDA yourself, and what are you doing? So imagine you're now the transition function yourself, and you have to look at the various things, that bits of information that are coming in, and then you have to decide on the basis of that information what you do next. Okay, so the input information. Well, now there will be three things rather than two, because now we're a PDA and we have a stack. So what are those three things? Well, current state, the current input symbol in your input stream. So those two are the same as before, the same as DFAs and non-deterministic finite automata. But now there's a third one, and that's relevant to the stack, and that is the element at the top of the stack. Okay, so you now have these three inputs, and on the basis of those three, you then choose to do something. Well, one will be the same. One thing of those, in fact, there'll be two things that you'll do. That's new. Now, the first thing is the same as before. You will choose the next state. Okay, that's just the same as we've done before with DFAs and NFAs. But the second thing, common sense, is you'll do something with the stack. You may or may not choose to push something onto the stack. And you might also choose to read and pop. Well, you'll do. The second thing is you'll do something with the stack. Okay, because you have a stack. Now this will become clarified how you manipulate the stack when we get into the formal definition and examples. But intuitively, sort of a hand wavy way, a bit vague. The second thing that your transition function is to do is to decide what to do with a stack. Okay, so the output, if you like, of your transition function is the next state, and what do you do with the stack, right? Now, so the transition function before gave you the next state, but this time the transition function is giving you several bits of information, not only the next state, but also what you do with the stack. So, you're doing two things. So now before we just said, transition function gives you next state. It was just one thing, and now we're getting two things. So let's get a generic term for those two things, and we'll just call it the next move, right? Because the transition function has to provide two sets of two bits of information, the next state and the next thing you do with the stack. So those two things together I just call a move. So the transition function now is providing, it's determining what the next move will be. Okay, a move being two things: next state and what you do with the stack. Okay, so this concept of next move. All right. So summarising a little bit before we get into the formal, the input, in a sense, to your the three input parameters, if you like, to your transition function will be current state, the current input string symbol being read, and the current symbol at the top of the stack. Okay, so there's three things. So now we can get more formal with the definition of the transition function, the delta. Now remember, it's a function. A transition function is still a function. What do functions do? They map an element of one set into an element of another set. So and the set that gets mapped from is called the domain. Remember? Go back to chapter 0. And the set that gets mapped to is called the range. Okay, so from the from set to the to set, from the domain to the range. Okay, so what is the domain for the transition function for a PDA? Well, it's here. Now it's sort of, now before we didn't have the gamma, right? We just had this Cartesian product of two sets. Well, now we've got this third factor, third parameter, if you like, in the transition function, which is concerned with a stack. So now we'll have a Cartesian product of three sets, okay? And an element of this Cartesian, now Cartesian product it results in a set, okay? And this Cartesian product of three sets, an element of that Cartesian product will be an ordered triple, right? Three numbers, like number 1, comma, number 2, comma, number 3. And ordered, where the order is important. And so for that ordered triple, the first number will be a state, second will be an input symbol in your input string, and your third will be a symbol at the top of the stack. And the state will belong to the set of states, Q. The current input symbol will be a member of your symbols for the input string, so capital sigma, and the third one will be a member of your set of symbols for the stack. So it'll be a member of the stack alphabet, well, modified by the epsilon. Similarly here, the second one will be a member of the input alphabet. Okay. So the current state, so remember this, that order triple, so the current state, the next input symbol read, the next input symbol read, right, and the top symbol of the stack. Okay, those three will determine the next move of the PDA. Remember, the next move is the next state and what you're going to do with the stack. And what you're going to do with the stack, that will become more concrete as we move on. Okay. Now, we're talking two symbols here. That's why we augmented them with the epsilon. The input symbol could be an epsilon, right? And what's on the stack could also be an epsilon. So now you can have a move. Let's see. So that you could have an epsilon here or here. Now, so that means you could read a symbol from the input stream. You could do a move, so you could have your output from the delta function. You could do a move without reading the symbol from the input stream, okay, or without reading the symbol from the stack. Right? If you have an eta in your ordered triple, if the second one is an epsilon, then you don't read the symbol in the input string. And if that's an epsilon, then you're not reading, you're not looking at the stack. Okay. All right. Now, similar. How about the range? Now, concerning the range, what about the range? Now, usually I just write RE. Also,